Right, class, including Philip, we are going to talk about the rules of probability. Well, I could have probably skipped this part, but I'm going to get right to it. So, what are some things we know about probability? P of A will always be what? Greater than 0, or equal to, or greater than or less than 1. Those are things we hold true. Sometimes a question might ask, is this possible? And they'll give you probabilities of events, and they can't be greater than 1 or less than 0. Oh my gosh, look at this. Now we have to see my face there the whole time. You guys know what I actually look like. No emails. Alright. Number 2, what else do we need to know? If I take all my possible outcomes and add up my probabilities, what should the sum of probabilities be if I'm combining all my outcomes? What do you guys think? If I have all my probability of outcomes. 1 is correct. They were all shouting 1 from the mountaintops. And don't forget that the probability of A of C, what's that mean? Of AC Slater? How's that for a reference? Saved by the Bell, anyone? A complement is always equal to 1 minus the probability of A occurring. Okay? Remember that this comes up quite a bit, because you can't always find the probability of something, but you can find the probability of not something. Alright, put this up here. There you go. Alright. You guys can see how I make these videos, how the magic happens. Alright, anything too scary? There's some other rules too. Like 6 rules. Alright. The next one is, what is probability of A? By definition, what is probability of A? It's number of outcomes with A over total number. So what could happen? What could happen with A over what could happen total, with or without A? So always think about probability as what you're looking for over what could happen. Now let's get to the nitty-gritty stuff you guys have all the questions about. And I can pull down, I think by the time we're done with the next 3 days, I can pull down like 4 post-its up there. Or no, 3. The one's about linear and about X and Y and how they relate, and that's a while. Now, if something's disjoint, these 2 words are interchangeable, okay? Disjoint and mutually exclusive mean the same thing. They mean they do not happen at the same time. They have no outcomes in common. If 2 things are disjoint, it means that the probability of A or B equals the probability of A plus the probability of B. So you just add them. Okay? So like if I want to know, if I'm rolling a dice and flipping a coin, and I want the probability of a heads or a 6, well, probability of a heads is a half. Probability of 6 is 1/6. Uh-oh. Might have overlap there. So that's mutually exclusive disjoint. You just add your probabilities. And you guys know if they aren't, you subtract the and. So keep that in the back of your head. We're going to be discovering that. And then the other one I want to talk about is, oh no. All right, now if they're independent, we've been talking about this. If they're independent, we're looking at the and. Independent means that the probability of one does not affect the probability of the other, right? So that'd be the probability of A and B equals the probability of A times the probability of B. Why are there so many different symbols for multiplication? Why is there like stars and asterisks and dots and times and an X? And then you just put them in parentheses? It's wild. Also, don't forget that and is also written like this. The intersection of them. Or is the U is a union. So union, intersection, right? So these symbols, this symbol means or, this symbol means and, right? Because it looks like an upside down A. That's not why, but that's sounds good. If anyone out there, if you know why, leave it in the comments. Don't smash that like button. Don't forget to hit the bell icon. Click subscribe. Links in the description. If you shop Amazon, click the link to buy your things. Because money. I like money too. Alright. Cool. Good talk. Alright, let's talk about distance learning. We've all been a part of distance learning this year. What a hoot. Oh, cool. There's not the question there. This is why I make so much money making videos. Shout out to anyone at the College Board. I applied to make videos for your website and you guys turned me down. So, you guys can make your money. Alright, so show that this is a legitimate probability model. If it's a legitimate probability model, common question, how would I show it? What do all my probabilities have to add to? Yes, Isaac. Yeah, they all add up to equal 1. So when I add these up, oh, I'm sorry, Frank the Tank. When I add all these up, they have to equal 1. Do they equal 1? Yes. So how would I write that? Sum of probs is 1. Equals 1. Alright. Yeah, I think you guys know how to do this. How would I do a probability of not 18 to 23? You do 1 minus that. Ta-da! 0.43. Yeah. I think I want you all. I'm actually going to go in reverse order. I'm going to give you, on this page, I'm going to give you the general addition rule, and then I want you to do A, B, and C. Like together on your own. So, again, I alluded to this at some time. If I'm finding the probability of A or B and they're not mutually exclusive, my formula changes, doesn't it? That's the probability of A plus the probability of B minus the overlap, right? The probability of A and B. Actually write that symbol. Okay? So now that you know that, I want you guys to try A through C. Pierced ears. So for just total pierced ears, I went with my total yeses over my total students, right? So I did 103 over 178. If you're real technical, that was 0.579. Yarnar. Yar. Thanks, Frank Jr. What about just a male with pierced ears? So that one I'm looking for the probability of a male and pierced, right? So now if it's an and, what do? Well, actually, I can just go like this. And be like, well, there's a male and pierced ears out of my total. There's nowhere where a 2 is involved in that problem. Alright, 178. Alright. Now, what about this one? Is a male or pierced ears. I'm going to do this the formula way because I want you guys to get used to seeing that. So I'm going to do the probability of a male plus the probability of pierced ears. But now because some males have pierced ears, we have to subtract the males who have pierced ears. I should have done this the whole time. So what's the probability of a boy? 90 over 178. What's the probability of pierced ears? Well, we have it up there, but I'll rewrite it. But now we have some boys who have pierced ears. So I subtract the overlap, and then I get my 174 over 178. So my probability of randomly attaining a male or someone with pierced ears would be 0.978. Okay. So now that we've seen this a few times, I'm hoping you guys... This is a very commonly used formula on the AP test. Yeah, they love it. And it's on your formula sheet, of course. All right, let's move onward. We're almost done, actually, for today. Ooh, I like this, actually. I like it a lot. So let's talk about Venn diagrams, because I know you guys love them. So if I wanted to show these events, how would I show A in its complement? If this was A, where would its complement go? Here. Because if you're not in A, you're not A. So you have someone else's grades and Mr. Terwilliger's grades. I don't get grades anymore. Now, what about mutually exclusive? Would mean that I have some A. And now when I put my circle for B, they will not overlap because they don't happen at the same time. There's no way they can happen at the same time. But now let's say we are looking at union, aka an A or B situation. Well, in that case, we have an A and we have a B. Oh, what? Oh my gosh. Lag much? Am I putting my finger in my ear? Gross. Don't look at that. I think I was itching it. It wasn't in there. Don't judge me. We all have ears and fingers. It happens. Alright, and B. And if I'm looking at the union of those two things, I'm talking about everything in both circles, right? Because when I'm looking at OR, it can be A or B. Because the intersection, the AND, I'm just looking at that piece, right? That's when they're both occurring. And I know you guys told me you don't like the Venn diagrams, but I'm going to show you another Venn diagram because I think you should be able to make a two-way table and a Venn diagram. You should be able to do both. All right, let's do one more example, and we'll call it a day there, buds. But this example is going to be multifaceted. All right, suppose in an apartment complex, 40% read USA Today, 25% read the New York Times, 10% don't know how to read, 5% read both papers. What are the chances, or let's find the different probabilities of stuff. Let's make a two-way table. Oh my gosh. Alright, that's not so bad. I've done worse. Alright, so I'm going to do New York Times and not New York Times. And I'm going to do USA Today and not USA Today. Okay? So then what do we know? We know 40% read the USA Today. So this total is 0.4, right? The total. Because remember, back here, these are always totals. All right, now 40% read the USA Today. That means 60% do not. I'll say no. New York Times, 25% read the New York Times. It's 0.25, 0.75. Are you good so far? And then remember, when you add across, they got to be equal when you add up and down. It's almost like a Sudoku or a Kakuro. You guys ever seen those puzzles? They're like Sudoku, but you're adding to equal same things. Like they give you the numbers at the end of the number sentences. They're actually a lot of fun. I used to do those in geometry sometimes with kids. I should. Now, what else do I know? I know that 5% read both. So that means 5% are U's and N's. Once I have that, can I fill in the rest? Yep. Because these two have to add to 0.25. So that means this has to be 0.2, read the New York Times and not USA Today. These down have to add up to 0.4. So that means 0.35, don't read the New York Times, but read the USA Today. And then across, they have to add up to 0.75 or up and down. This is a good way to check yourself. Does it work both directions? It does. And that's my two-way table. Now, if you a lot of questions you can answer with a two-way table, or you can be using equations to figure it out. You know what I mean? To find like your ands and your ors and such. So let's make a Venn diagram. So again, I'm going to make New York Times, USA Today. Now this one we have to do some thinking. So 0.4 read the, I'm going to pretend like I don't know this up here. Pretend like I'm going into it blind. I know 5% read both, right? And I know number one mistake is people are going to read that 40% read New York Times and they put 0.4 right here. But now remember, this whole circle's 0.4. And now it's 0.45 because of that 0.4. So this is actually 0.35. Because these have to add to equal 0.4. And then for USA Today, I know is I read that wrong. Watch this though. What I meant to say was, this is my USA Today, and this is my New York Times, of course. History will be kind to me, for I intend to write it. Winston Churchill. Mr. Twilliger. Alright, New York Times is 0.25, so I know it's 0.2, because these have to add to 0.25. And then I'm left with who doesn't do either. Well, you add all these up and subtract it from 1. So I get whatever, 0.6. So that means 0.4 read none of them. And that's your Venn diagram. Okay? Both ways work. Because now answering our questions is going to be really... If you start with a Venn diagram instead of using the equations, when you go to answer your questions, you don't have to do math. You just look back at your Venn diagram. Like, hopefully if your packets at home, like on C, what's the probability that they read at least one of the two papers? So for C, that's the probability of A or B, right? Or I'm sorry, I'm going to do N or U. Oh, I shouldn't have used U. So for or, that means what? What's the probability that I read one of them? Now, you could do 1 minus the probability that you don't read any, and it's 0.6. Or you could just add up all the numbers in your Venn diagram, right? Because what's the probability you read a paper? You add all those up. Either way, you get 0.6. Or what you could have done is you could have done the probability of N plus the probability of U minus the probability of U and N. So you would have went 0.4 plus 0.25 minus 0.05. So that's 3 ways to do one problem. Okay, you could have used the formula, the probability of U plus probability of N minus the probability of U and N, right? Okay, so you could have done that problem without a Venn diagram, with a Venn diagram. Either way is fine. And what's the probability they don't read either paper? Well, that 0.4 was the probability they don't read any paper. Now, you could have done that with a formula too, and done the probability of... Oh no, that's not an or, that'd be an and. You do 1 minus your probability from C, but we did that for backwards. But yeah, there's multiple ways to cook a cookie. Yeah, good talk, guys. I hope you enjoy in there, wherever you are in this. Oh.